One of the issues with canola is that canola has a great deal of seed losses associated with it at the time of harvest. It's different than most of our other crops in that it might not be quite as domesticated as many of our other crops, in that we haven't gotten or haven't been able to reduce that seed shatter and pod drop and harvest losses in canola. There's obviously a lot of interest in reducing those two phenomena, and they are separate phenomena. A way to do that is to better understand that is to look at methods that we can use to estimate pod drop and seed shatter. There's interest from industry to do that because they're obviously interested in developing canola genotypes and varieties that have lower harvest losses associated with them. But one of the problems is that there is no standard accepted method for estimating these two phenomena. And so the objectives of this project were to look at the various methods that have been developed and maybe even think about new methods that we can use to estimate pod drop and seed shatter, and also look at how efficient and effective these methods are. Some of the traditional methods are very time consuming, but they're quite accurate, and others maybe less accurate and less time consuming. So the goal here was to compare these traditional methods and maybe look at some new ones. So the methods that we compared were seed shatter ratings, which is a common method. We also used catch trays. These are trays that are placed into the between canola plants, between rows, that catch the seed and pods that fall off prior to harvest. We used the catch trays so they were inserted at the time of flowering or pod fill before there was any chance of pods to drop or seeds to shatter. And they were left in the canola crop until the day of harvest. And the other method that we compared, or another method that we compared this to, was the vacuum method that I used during certainly my PhD studies to look at total harvest losses. And this is where you would go out into the field after harvest, and you can really only do it after harvest, and vacuum up the seeds that are left on the soil surface with a shop vac, and then separate those seeds back out from the soil, which is a pretty time-consuming, laborious process. So that is, in terms of accuracy, probably the best method that we know of, or one of the better methods, but is very, very time-consuming. Other methods that we tried to pioneer were digital imagery of seeds on the ground and of pods. The real problem with digital imagery we found very early on was that canola seeds are black and so is soil, so there really isn't a very good piece of software that's readily available or wouldn't take a lot of modification to do a good job at that. And very similar with pods, full drop pods and pods that have shattered, their color differences, although we see it very easily with our naked eye, digital imaging analysis software really can't pick that up. So those methods, although they had some sort of potential early on, we thought are very difficult with at least the software as it exists today. The other methods then that we compared then were the catch trays. The beauty of the catch trays, that method, is that it allows us to measure pod drop and seed shatter independently, because the catch trays actually catch the seeds that fall off the plant as the pods split open and shatter, and those pods are still attached to the plant. And the catch tray also catches the pods that fall right off the plant that are full. So it's a very good method for estimating or comparing those two different phenomena, being seed shatter and pod drop. The visual rating method that we used was mostly for seed shatter. It's relatively easy to do because you see the siliques, but the split open silique has the membrane between it, and you will see those quite clearly as the pods for seed shatter are still on the plant. We didn't rate pod drop on the ground. It's a little more difficult because there's a lot of leaf residue and leaf litter on the ground. So we didn't do a visual rating for that, but the seed shatter ratings correlated quite well with the tray-based method. The seed shatter, of course, being a relative rating, and we had a couple of people rate, and they came out with relatively similar ratings. And the tray method being a way to absolutely quantify that, and they correlated quite well. The harvest losses, the total harvest losses with the tray also correlated, so that pod drop and seed shatter, once we separated all the seeds from the tray, those correlated quite well with the vacuum method. And even though the tray method covers a smaller area and so has those challenges of large variability between trays, because we're basing our estimate on a relatively small area, whereas with the vacuum method we can do a much larger area, the correlation was actually quite good, despite the fact that the vacuum method also included combine losses, whereas the tray method, because we had to pull out these trays before harvest and inserting them again before harvest into a mature canola stand, also causes losses. We didn't want to do that. So the two methods actually measure something quite different, or not quite different, but different, in that the trays only measured pre-harvest losses. The vacuum method measured total harvest losses. The trays and the vacuum method correlated very, very well. Were there differences? One of the questions we wanted to also address, which was an objective of the research, was were there differences between open pollinated, the more traditional varieties, and the newer hybrids in terms of pod drop and seed shatter? Now, the newer hybrids tend to have larger seeds, and so the hypothesis or the question was, because hybrids have larger seeds, does that result in more pod drops, i.e. the pods being heavier and they're therefore more likely to drop before they get a chance to shatter? So we addressed that question, and the tray method was perfect for addressing that. And interestingly enough, that wasn't the case at all. In fact, we saw on average probably a bit more seed shatter in the hybrid varieties than we did in the OPs. If there were differences, there weren't always differences. There's quite a range in the 4 varieties that we tested that were hybrids. There's quite a range in pod drop and seed shatter among those varieties, as there were among the OP varieties. So there certainly are large differences between varieties, and a fair bit of overlap between those categories. But when we compared the categories, we certainly couldn't show that pod drop is greater in hybrid varieties than in OP varieties. And in fact, when there was a difference, seed shatter was greater in the hybrids, but that is only when there was a difference. The other thing that we found is we used the tray method also to compare whether pod drop and seed shatter are related events, meaning that if a variety has high pod drop, will it also have high seed shatter? Because if they're related, then we only need to measure one and we get a good estimate of the other. Turns out that, in fact, that's not the case either. There's really no relationship there, neither positive or negative. So seed shatter and pod drop tended to be very independent of each other. And just because of one variety had greater seed shatter didn't mean that it either had greater pod drop or lower pod drop. There just was no relationship there, which for perhaps industry, to improve varieties, canola varieties, that means that we have to look at both phenomena. We can't just measure one and say that we're going to get an improvement in both. So again, we have to measure them both separately. Pod drop is a relatively difficult thing to measure. I mean, with trays we can do it, but it's very difficult to estimate otherwise. You can't look at a plant easily and say, well, this is how much pod drop there was. You have to look at the ground, and maybe that'll give you an indication. But again, it's a very difficult thing to rate. So one of the new methods that we've tried out was also to measure pod retention resistance, which is a measurement of the force that is required to pull the pod off the plant. And that method, although it needs a fair bit of refining still, and we are continuing that research, has some potential to be a relatively rapid method to estimate pod drop in canola varieties, which of course the industry, again, like I said earlier, is interested in, because they are looking for improvements to reduce harvest losses from several perspectives. And also one of the main reasons for reducing harvest losses will probably also be that the producers are looking to straight cut canola, and to do that successfully over the long term, I think we do need probably varieties that are much more resistant to losing their seeds at harvest, before harvest, during harvest.